Alright, so hopefully the stream is working for everybody. I just reset my internet. Looks like the upload is good again. Alright, so I was conjecturing about whether we could just reuse map.any or like extract fold out of there. I guess there's a difference because any is a short circuit where it exits early. And fold always has to go through the entire map. So let's see if we can write the fold real quickly. We're going to have fold. This is going to take a function that takes a file and a, gives a new a, and it starts with an initial value, and then takes a map and gives back the final a. Just to compare, fold L. So if we look at list.fold, we have a very similar structure. A function, the initial value, a list, and our resulting value. Okay. So this is going to recurse in a very similar way. So I think I'm just going to basically copy how we did the work for any. Have a fold, the function, the starting value again, and map itself, and 0.00. And fold prime, just going to recurse in essentially the same way that any does, except will never terminate early. Have this. We're also point, so we have our function, our initial value, our map, our point, which I will destructure as x comma y. I'm going to start with our any as our starting code. All right, so we're going to find the tile. Then we don't actually care about the predicate. We're always going to jump into this recursive part. And if we're past the end, we're just going to take this. This is the current value of the accumulator. So we'll return that if we're done. If we're not done, we're going to call fold prime again and recurse, passing the function, the new value of the accumulator. So actually this can be called in. New value is going to be calling the function with the tile with the previous value. It'll give us back the new value. The new value is what we want to return if we're done. If we're not done, the new value is what we want to pass in to the next step in the fold. And the same thing here. If we're not done with this row, we're going to recurse, pass the same function, pass the new value, pass the same map, and advance to the next point. Okay. So you may want to work through that as an example on your own and maybe write some tests if you want to get some practice with recursion. But I think that should be good. And then map doesn't expose fold, so let's expose it. All right, let's try to run our tests. Great. So I think we have the failure we want. We got one grass tile and we expected it to be greater than 10. Cool. So I think there's a quick fix for that. All we need to do is set our default tile to be grass. Damn. That should solve that test. Now, let's move on to the harder one, where we want to also have more than 10% road. I'm going to copy this whole thing, change this to road, and pull that out. Yes, it's no longer waterland, it's now grassland. Alright, so now we have our failing test. And it should contain at least 10% road, and it does not. So, right. So how do we want to implement this? So one thing we could do is maybe extend the road from this one point. So we could go through and just add, actually, 1, 1, 1. What I meant to do was change this to be -1. Then we'll have a +1. We can kind of build out a segment of road. Centered around some particular location. So that's not going to pass our test yet, but we're up to 4 roads. So maybe we can add a second road segment. That seems reasonable. And it'll also kind of look more realistic rather than just like trying to randomly place pieces of road at different points. So why don't we add a second point for a second road. Now, instead of random.map, I think there's a random.map too. Let's check the docs. Random package. There's map. Yeah, here's map2, which takes a 2-argument function and 2 generators and creates a generator. We're going to use map2 and pass a second pair. And then let's grab this then and make a second road that's at a different y position. So for all these, we're going to maybe do a 4. Okay. So there's some road. Oh, right. And then I didn't change this to use the second parameter for the second point. All right. So there we've got some random roads. I think our tests still are not going to pass. So seed 0. Go to our main. Turn this off. So here's our seed 0 map. Doesn't have enough road. Really? So maybe we can add a third point, maybe put a vertical road at that third point. And I think we should maybe extract this into a let block as well. We'll have add first road. And we'll take all the stuff related to the first road, do that. We'll take the rest of this, call it add second road. All right. Still the same. Now we're going to pull out this third point, R3x, R3y. And let's add a third road. And we'll do that here. And all of these we change to R3. All right. And oh, actually, I wanted to make these this particular road more vertical, or excuse me, yeah, vertical rather than horizontal. So let's just swap all of these. +3, and these will all become, oh, well, these can all just become constant. Just stick it at the point. All right, let's see how our test is. We're doing better. Got 8 points. Maybe we should just go all the way up, down with this one. We'll need to subtract more. All right. There we go. I'm actually just going to run this a few times. Okay, and let's turn on our main again. All right, so we're starting to get some random mapness going on. And we have also proven with our property tests that that we have at least 10 tiles of road and 10 tiles of grass on every map. And maybe there's a couple random cases that the tests haven't actually exercised yet. Possible. That's one interesting thing with property tests or fuzz tests, is that you may have passing tests for a long time, and if there's a very obscure case, it may randomly come up in the future. But the nice thing about Elm test is, like we saw earlier, it always prints out the seed when there's a test failure, so you can go and inspect that specific case. All right. So let's see, why don't we try adding some buildings? So my tile set has a couple defined specific exits. Yeah, okay. So there's like an armor shop, a weapon shop, inn. So those are 3 easy buildings we can add. So let's try checking that, and let's say that there should be 1 inn and at least 1 of these other shops as well. let's go to our test. Cool. So let's write a fuzz test. We're going to do the same pattern with fuzz.int as exactly one in the town. So we're going to use the same boilerplate. We can probably extract a helper function for the way we're doing our fuzz test here, but I'm not going to worry about that quite yet. So we're going to get our map, then we're going to fold over it and count the number of ins, and we're going to expect it to equal 1. So actually, why don't we extract this into a helper function, call it count tiles, and we'll pass it a parameter. And count tiles, I'm going to take a string and give an int back. And what else does it take? It also takes a map. And then it's going to be this. And rather than in, we're going to count whatever tile we're asked to. Pass the map. Okay. Now we have this nice helper function. That means we can simplify this test as well and say count tiles road is greater than 10. Same thing here. Count tiles grass should be greater than 10. Okay, yeah, those tests look a lot nicer now. Alright, so we should have a failing test. What? Thinks there's 111 ins. Okay, that's because we are checking. Okay, my assertion's wrong here. We have overlapping variables called tile. So this will be called tile to count. Also, we apparently have a problem with our fold because it's folding over too much. It should only be folding over 100 tiles. So that's maybe a problem to look into later. All right. Yeah, every square foot of this town is an inn. That is way too many inns. What kind of economy do they have there? I mean, I guess it's a fantasy game. They can have whatever kind of economy they want. All right. So we have no inns. We need at least one. So, well, here's an easy thing we can do. We'll just add it. Let's always put it at 3, 4. There it is. So that test passes. What I think is really great about these fuzz tests for random generation is that we can add more randomness later, and the fuzz tests will still give us good coverage. So like here I've just hard-coded the in position, but if we wanted to refactor this and make the in position move, we still have test coverage from all of our tests. So actually, like, if we put the in first, then potentially one of the roads could overwrite it. Let's see, we get a failure. Yeah, look at this. So here, our fuzz tests are actually doing quite a bit of coverage. How many examples are there? Great. Yeah, it looks like it's doing a bunch of examples. That's a problem because the in these examples, I'm assuming, is getting overwritten by the roads that we add later. We add the in last. then, ooh, we still got some failures. Oh, interesting. We have some cases where we don't have enough road anymore. Presumably because the in is overwriting some of that road. So why don't we add a bit more road then? Let's just extend a few of these. And this one, 4, -5. Okay, try this again. Cool. And let's see what else. Oh yeah, so we want to add the armor shop, weapon shop. So let's add tests for this as well. As at least one armor shop, as at least one weapon shop. This should be greater than 0. This one should also be greater than 0. Cool. So we got some failures. So let's quickly add those to our map as well. There they are, all in a row. And let's see how our tests do. Okay, so we have our seed 43. Needs more road. Let's take a look at that one. So if we go to our main, and if we stop generating random ones, put in our seed here. All right. So here is that particular road, or that particular map. Interesting. Okay. So here's maybe something we can do. Why don't we try this? We can say if the place that we are placing this door over is a road already, then we should like move the road to be next to the door or something like that. So that should help these cases that are slowly or that are occasionally failing. Let's see if we can do something like that. In our town map, I want to add the in, but then I also want to say actually want to say if okay, so I guess we need a function here. Why don't we do this first? Move road at 3, 4. What's this going to do? This is going to be a function. It's going to take a point, x, y, and it's also going to take our dictionary that we're building up. It needs to give back a new dictionary for our pipeline. What I want to do is check and see if the current location has a road on it. Then we're going to put road to the left. So let's try that. So we'll say if dict.get x, y from the dictionary if it's just road, then we're going to return the dictionary with inserting the left, so that'll be x minus 1 comma y, road there. Otherwise, we'll just return the dictionary. Alright, what did I do wrong here? Branches produce different results. Oh, I forgot to pass the dictionary to insert. Okay. So I believe what this should do, oh yeah, and we can see it here in the example. So there was road at this location, so it put road to the left side. Why don't we do all of these? 5, 6. There we go. And actually, to make this nice, if we're moving the road, why don't we also add the corner spots? I'm going to switch this to use a pipeline here. So rather than just putting road in this one spot to the left, let's also put the road above and below this spot to the left so that it actually will connect to any adjacent existing road. 2 minus 1, this will be plus 0. This will be y plus 1. Yeah, there we go. That looks pretty nice. So let's try our test again. Hopefully this will pass. Cool. So let's go and turn back on our randomness. Cool. So if we ever place the doors on top of road, then we add extra road to connect the doors. I guess now we have a problem where the doors may not be connected to road. So I wonder if we can, what property we can implement to solve that. Actually, why don't we take a short break? I need to run to the restroom and refill my water. So here's the question I want to propose. We have this map. If we place doors overlapping roads, we add extra road to kind of connect the doors. But you can see we often have cases where the doors are just out in the middle of a field. I think what we should try to do is connect the doors to the roadways if they're out unconnected. So what kind of test could we write, or what kind of property test could we write to assert on that, and what kind of algorithm could we use to actually connect the doors if we find they're not connected? So think on that for a few minutes. Let me make sure this is all pushed up. So we added our fold. We added a bunch of more roads. We added the doors for the buildings. And we added our README. So we generated some doors and buildings. Cool. So while you all, and I'll be thinking about this too in the next couple minutes, so let's take a short break, and we will be back shortly to add on to where we're at.